Mesh analysis is a duet pair for nodal analysis. We know that nodal analysis, we need to define the node, the reference node, and then we want to find the node voltage using KCL on the node. So node analysis, we look at voltage on the node and use KCL. For mesh analysis, we want to look at a mesh, which is a loop, and we want to apply KVL on the mesh, which is a loop. We want to find the current of the mesh. Those two methods of analysis are duet pair. Let's define a mesh first. Mesh is a loop. First of all, it's a loop, but it is a loop that does not contain other loops. Think of mesh. This is a mesh. This is a mesh. This is a mesh. You can see the mesh is a loop but does not contain other loops. So this is exactly what we say here. This is a mesh here. This is because it's a one loop. This is a mesh here. But this big one here, this big one here is not a mesh. Let's define mesh current. Mesh current is different than branch current. So this is a branch current, I1, I2, I3, and I4. These are branch current. Those are current flow through this branch. This is I1, flow through this branch. This is I3, flow through this branch. And I4, that's this current flow this branch. So this and I2, most importantly, I2, this is current flow this branch. So branch current is defined with respect to a branch. Then what is mesh current? Mesh current is the current flow through this mesh. And this is the current flow this mesh. So normally we do this direction. So this is a clockwise. So the notation of a mesh current, the current in this mesh is IA. The current in this mesh is IB. So this is the mesh current direction that's flowed this way. And IB is flowed this way as well. So normally for simplicity, and we always define the mesh current direction clockwise. But if you want to define different way, you can, nothing wrong with that. Just be a little careful with the directions. Next, for branch current I1 actually equals to IA, which is mesh current, because there's no other mesh. There's no other mesh connected to this branch. And then what is I3? I3, that's equals to IB. That's a mesh current because this branch does not have other mesh connected to it. So I3 equals to IB. What about I4? I4 equals to IB as well. I4 equals to IB because this branch does not have any other mesh connect to it. Now let's look at I2. I2, that's the branch. I'm going to use different color. I2, that's the branch current flow into this branch. But this branch is a common branch for this mesh and this mesh. This branch current I2, look at this is a direction here. This is a IA. This is IA, this direction, and then this is actually IB. IA minus IB, because IA is the same direction of I2 and IB, that's opposite direction. So therefore I2 equals IA minus IB. So these are the relationship of mesh current and the branch current. This is very important when applying mesh analysis, and this is also the place where lots of mistakes can be made. Get an example of this circuit to see how we apply mesh analysis. So our first step is to determine the mesh. So here we only have two mesh. This is one loop, and this loop does not contain other loops. So this is a mesh. And then we define mesh current this way here, IA, and this is IB. That's step one. Step two is use KVL in each mesh. Mesh is a loop. Mesh is a loop. It's a special loop. The loop does not contain other loops. So mesh is a loop. It is one special kind of loop. To apply KVL, so you just walk through this loop, through this mesh here, and you go here, this direction. First element will be minus VS1 here, and then V1 here, this is the voltage on R1, and then look, R2, the voltage on R2, that's V3, that's the positive sign, this is the negative sign. So that will be plus V3. And then after that, it come back to the same point, that equals to 0. That's mesh 1. Mesh 2, the same thing here. So I can start here. So the first is minus V3, that's this term. And then V2, right? And then plus VS2 here. VS2, that's this term. And then I come back to the same place. That's equals to 0. So this is KVL for each loop, for each mesh. Next step is to apply Ohm's law to get rid of V1 and all of those voltages we want to express as the function of the mesh current. So V1 use Ohm's law, that's the branch current, multiply branch current on this branch multiplied by R1. What is that? That's IA multiplied by R1. And then V3, that's the voltage here, that's the current flow through R2 multiplied by R2. So what's the current flow through R2? That's IA, and minus IB, IA minus IB. So the same thing here. This is V3, that's the same thing. And what is V2 here? V2 is the voltage on R3. So R3 multiplied by the current flow through R3, which is IB, that's this branch current, is equals to the mesh current IB. Now we have two equations here, two unknowns, IA and IB. So we can write the matrix form. So like A is a matrix. In this case, it will be 2 by 2 multiplied by, what are those unknowns? IA, IB. What that equals to? That equals to something here, something here. So this may be something here and something here. You organize this two equation into a matrix form. So IA and IB, and basically you have this format here. Bx equals to B, x equals A inverse multiplied by B.